There is data and you have to be a scientist. What is a scientist? You take some observational stuff, you make sense out of it. You derive insights from it using a bunch of scientific tools.
Got it.
In data science, it is mostly math and code. A lot of people directly jump to the most complex model possible because they want to show that I am the Sheldon. Tools don't matter to me. You use any tool, boss. Tell me what is the insight and justify that insight from first principles. That's all. You can do it using GPUs, I don't care. Do it using Excel, you do it using Google Sheets, I don't care.
Right.
I want insight. I wrote my GATE exam. I got All India rank 2.
Wow.
And I was clear. In my 4th year, something interesting happened. I started liking this thing called artificial neural networks. We had an elective. I always loved math in general, but I also fell in love with systems a little during my BTech. So I often tell in the classes that in mathematics, equations are like poetry. They are a crisp way to explain a very deep concept.
Right.
And plots or diagrams are like the art of mathematics. So if you want to build an AI deep tech company,
Right.
always start with a problem. Please don't. I see a lot of people who have a hammer and they're looking for a nail. At Scaler, the last 7 months has been terrific because I love building things from ground up. While it's hard, it's fun because that's where you have great stories to tell your grandchildren.
Yeah.
Otherwise, what's the fun of doing all this? Like, I think that's the part of the day where by 11:50, 11:30 when the class is over, I'm like super happy. I think a lot of these diffusion models or stable diffusion Galileo will become enablers where non-artists like me can still create great art, infusing my personality into it.
Yeah.
So it is democratizing that access. So at the end of the day, know some tools, but be flexible to learn new things as they arise.
Hi, welcome to yet another episode of ScalerPod. And today we have with us someone very close to home. So Varma, that's what everybody knows him by. And he's the founder of Applied Roots and now heading our data science vertical at Scaler. Thank you for coming.
We are here all day.
Right. So I'll start off with a question that I start with everybody, all my guests at ScalerPod so far, which is what does your day look like right now?
Right now, okay. Yeah. So my day gets split between two things. We still run Applied Roots. We have learners that we want them to succeed. And of course, we are building the whole Scaler's data science and machine learning program, which is like doing a startup within a startup.
Right.
So most important things for me on a day-to-day basis is, first thing is just make sure that all of our classes that are scheduled, because at the end of the day in EdTech, it is instruction which is the core.
Right.
And I have regular conversations with all of our instructors to make sure that what we are delivering to our learners is the best thing possible.
Right.
That is super duper important. So a lot of hiring, we have hired very aggressively, and hiring is never easy, especially when we set our bar so high.
Right.
So hiring takes a lot of time. Mentoring, when instructors join us, they may be terrific scientists and engineers, but we also have to make them great teachers.
Right.
And teaching may or may not come naturally to everyone. So a lot of mentorship, training of instructors. And at the same time, I make sure that I talk to at least a few learners every day on regular basis, because I don't want to lose the pulse of the learner. I do this both at Applied Roots and at Scaler, because that gives me regular feedback. And I tell our teams that give me the people who are having the hardest problems or the trickiest problems.
Right.
Because that's how I know what's happening on the customer front. Like, I come from the world of Amazon with customer obsession deeply ingrained in me.
Yes.
So I want to constantly talk to learners who are our customers here. One of our customers, not the only customer.
Right.
Then I also spend good amount of time with our careers team. Because as some of our batches and cohorts have been progressing at Scaler, I need to make sure that what we are preparing our learners for is in sync with what the industry wants. Yeah. Another set of customers we have are recruiters. Oh, of course. Equally important customers for us. So I have conversations with engineering managers, leaders in the industry, to just make sure that what we are teaching is completely aligned with what they would want. And I want to make sure that they're excited to hire from Scaler.
Right.
So this is what happens in most of the regular hours of the day. But the best part of my day is typically 9 p.m. to 11 p.m.
Teaching.
So I'm very clear that I don't want to stop teaching.
Yeah.
Because I end my day on a very high note. Like I might take like 2 to 3 hours to prepare. if it's a topic or if I have to read a few research papers, which I've read long back and I've forgotten the nitty-gritty details. So I spend my late evenings, like 7 to 9, I read, I prepare my notes, or I try to improve my notes slightly, or I take notes from our other instructors and try to improvise. And then 9 to 11 is pure bliss for me. Like, I think that's the part of the day where by 11:50, 11:30, when the class is over, I'm like super happy. Time to go for bed. Again, the cycle repeats.
Right. I think I also teach classes, and I think like however the day has been, like high energy, low energy, things have
Good,
worked, things
bad,
have not worked. Yeah.
firefighting.
But 9 p.m. energy goes very
Yes.
high. Happiness also goes very high because
Surprisingly, even though the day has been hectic, I never yawn from 8 p.m. to 11:30
Yes,
p.m.
yes, yes, that never
because it's
happens.
like you're in like pure bliss.
Correct. Yeah. Love. I also love taking the classes. That's definitely there. The next question that I had was also a little bit about wanted to know about your journey. So like starting from the college days and going through Amazon, and then how applied roots also came into being. Right. So how has this journey been? What are the things you have been doing since college days?
Yeah, my journey is a very twists and turns one. But in retrospective, that was the best thing that happened to me. So I didn't do well in IIT JEE. I studied in a military school till my 12th grade. It's called Rashtriya Military College in Dehradun, where the Indian Armed Forces have taught us discipline and what to do and what not to do. They taught us a very simple thing. If you're put anywhere in the world, you have to learn to survive and most importantly, excel.
Right.
वो तो सिखाया हमको.
Correct.
Okay. I didn't prepare for IIT JEE. I messed up. I hardly prepared. Then I went into an engineering college called Sanketa Vijaya Parishad in Visakhapatnam,
Okay.
which is my hometown. And I was the first batch.
Okay.
When
New
I
college.
joined, I was the first batch of the college. So I aspired to go to the best universities of the world and ended up here. But again, what the school taught me for 5 years in Dehradun, the military school taught me is wherever you are, you excel and build your way out. You're thrown in a jungle, you find food, you survive and you win. So I was extremely upset when I joined the college. Like I was like extremely upset. But the good thing was at the same time MIT OCW was getting launched.
Okay.
Open courseware
Open
of
courseware,
MIT
yeah,
around
yeah.
2002.
Right.
And I said, that's okay. Some of the top universities are putting out the resources and we hardly had any faculty.
Right.
Some of the faculty we had were just graduated and they came back to teach us.
Right.
So things were not great at that point of time. But I learned through resources that were publicly available. I would just Google and say, hey, what is the textbook that MIT was using for their data structures algorithms?
Right.
I learned about this book called CLRS.
CLRS.
I said, okay, let's get it. We can read the same book and learn from the same resources. So it turned, and we didn't have labs. The microprocessor lab that we did, we actually learned what microprocessors to use, what kits to buy from other colleges. And we ordered them, got them, and did labs ourselves.
Wow.
In retrospective, what I learned then about microprocessors still helps me today when we have to write code which is optimized, like it's a deep learning code that is optimized for Xeon processors.
Right.
Right? So actually, not going to a top university was super helpful in retrospective because we did everything on our own. What better way to learn? It's unbeatable. 4 years in college, I was thankfully a topper. Things went well. I wrote the GATE exam.
Okay.
Because I applied to a few companies like Microsoft, DE Shaw, etc. This was around 2007. And I didn't get a call back.
Okay.
I can completely understand. They would have thousands of people who will apply. And somebody coming from a small engineering college, the probability of that person clearing their interviews is low at that point of time.
Yeah.
So probably I never got a call back. I wrote my GATE exam. I got All India rank 2.
Wow.
And I was clear. In my 4th year, something interesting happened. I started liking this thing called artificial neural networks. We had an elective. I always loved math in general. But I also fell in love with systems a little during my BTech. But these artificial neural networks felt like magic to me, literally like magic. So I said, okay, I got All India rank 2. I can go to any university for my master's.
Yeah.
I picked Indian Institute of Science right here in Bangalore. The best part about that was they had the best faculty and infrastructure for learning machine learning and AI.
Okay.
I go to the university, I go to the best prof at that point of time and tell him, he became my advisor later, Professor Chiranjip. Told him, I want to learn AI. I didn't know the word machine learning. I said, I want to learn AI. He gave me a list of most math-heavy courses. And I got screwed in the first semester. Because the courses are very heavy. You're competing with the best faculty. You're learning from the best faculty, competing with the best students.
Right.
But in retrospective, it is good because my math foundations become very strong. And I was also very fortunate because of Professor Chiru at IISc also wanted to do practical work. So we did some fun things. For example, one of the things that we did was, hey, IPL was just getting started.
Right.
This was around 2008, 2009. We said, let a match happen in real time. Can I extract 4 sixes and wickets automatically from the video feed?
Okay.
This was a project we did in summer just for kicks.
Okay.
And my lab, the Professor Chiranjeev had, it encouraged that thing. He said, let's do it, guys. What's there? It can't be rocket science. We can do it.
Yeah.
So thankfully, in addition to learning a lot of theory, dense, deep mathematical theory, I was fortunate to have had also got some real world experience.
Right.
Then placements come, I joined Yahoo Labs.
Okay.
Again, out of sheer luck. I told you, right? I got lucky so many times that I can't even count.
Right.
It was the very early years when Yahoo Labs in India was hiring people without a PhD for machine learning roles.
Okay.
I didn't have a PhD. I was just a master's student.
Masters.
And they gave me a research engineer. And I was put in a project where I was the youngest guy. And I had terrific team. Like I had somebody who was a stats PhD. I had somebody who has been a PhD, built actually large scale systems. And in the first 1 week of my job, my manager, like I challenged my manager in the first 1 week.
Right.
I told him, why are you using these simple models called logistic regression? You should use SVMs and all that. I studied this for 2 years at IISc. He challenged me. He said, take this data. We were using Hadoop clusters. We were the early teams using Hadoop clusters in 2008, 2009 time. And he said, build SVM model on this. Then I realized what industrial engineering is.
Right.
All the theory is great, but when you have to solve a real problem in the real world, everything is different.
Right.
You can't get low latency with it. You can't even train the bloody model in the first place. Right? Yeah. So I got grounded. Then I said, boss, I want to learn from you guys. I'm the youngest. So I'll do all sorts of crazy mistakes. Please excuse me and teach me.
Right.
So Yahoo was a great experience in terms of learning from industrial mentors. All these people are still great friends. They're still my mentors today. Then, of course, I always want to do a startup. So I said, I've saved enough money from Yahoo days. Let's build something. I knew computer vision very well.
Right.
So along with a friend of mine, Chaitanya from IISc days, we started building a computer vision startup. This was in 2010.
Okay.
We said, let's take a smartphone, take a video, just a video of you, and it will create a 3D model of you.
Okay, nice.
Fancy, beautiful, looks interesting.
Yeah.
But what business problem are you solving? What customer issue are you solving?
Yeah.
We never thought of it. We said, we had saved enough money. We said, let's run the show.
Yeah.
We quickly learned that we are solving nobody's problem. We are just building something that we think is cool and that we have a capability to build. We built all of the tech.
Yeah.
We soon realized that we are not solving anybody's problem. We are not improving the world in any way. We are just building things for our own satisfaction.
With something like that, I remember when Google AR initially came out, you could take your phone, do like this. And it was a fad, but then
so what we built was a fad, to put it bluntly. We burnt our money. We got shortlisted for Y Combinator.
Okay.
And we went to the Y Combinator interview. I really loved what the feedback they gave us. They said, you guys are good engineers, but you're solving nobody's problem. And that hit hard. Then we said, boss, there are so many things that we don't know. We have burnt our money. We avoided raising capital. We said, till the time I don't have a product, I will never raise capital from family and friends also. Forget about angels, etc. From family and friends also. I can't take anybody's money without me having the conviction that I'll make good returns for them.
Right.
So we shut down. Thankfully, we joined Amazon at that point of time.
Okay.
Amazon was just setting up their ad tech team in India.
Okay.
And some of my colleagues from Yahoo Labs days, some of my seniors also were also joining here. Amazon was a great time of learning.
That was when I think Amazon, Jeff Bezos used to say that he will never do ads, but then he was changing his mind, I think.
Not exactly. Amazon has been doing ads for a very long time.
Okay.
It's not about not doing ads. I think we are confusing two things. Amazon would not do ads on TV or Super Bowl.
Got it. Yeah.
Amazon always had some form of ads or other.
Inside the Amazon homepage.
Inside the homepage, search results, somewhere here or there were ads. Right. Because the philosophy then was that if ads were generating high profit margin revenue for us,
right,
we can always discount our products. It's simple logic.
Simple logic, yeah.
Right? See, today you're getting Google for free because of ads. While I dislike ads,
Yeah.
That is what is powering the internet.
Correct.
It's also powering bad things like social media and social media addiction and all that.
Yeah.
But look at pure search, no?
Correct.
Search is like
Search-
godsend.
Yeah.
So while I've made my truce with ads, that while they're not always good, they make internet free for a lot of people.
I mean, it gives a economic freewheel that otherwise it's not possible.
Otherwise, how many people in the world today, especially in the developing world, can pay for Google? There are a lot of people who don't pay for YouTube Premium.
Yeah.
But still, they have the whole YouTube learning resources at their disposal.
True.
So Yahoo, I was one of the earliest scientists in the whole ads org. So there, the whole, everything was open. I was sitting on like hundreds of terabytes of data, which became petabytes very quickly. And then nobody was building anything with it. So I had the front row seat of building lot of core machine learning and engineering things and how to think from a customer perspective.
Yeah.
Because
Amazon means.
Amazon is customer obsession, boss. I always tell people I did my MBA from Amazon. And even today, when I have meetings with my teammates, I keep saying, I disagree and commit. I keep using the same terminology. I say frugality.
Yeah.
Why should I stay in a very expensive hotel when something close by, like we have a OYO right next door, which is comfortable. I just need a bed to sleep,
Yeah.
which is 2 minutes walk for me. I would rather stay there. So frugality, customer obsession, all of that became the driving principles.
True.
From then till now, for almost the last 12, 13 years.
Yeah, that I've seen some large American companies. I got a chance to work at a competitor for Amazon, which is Target. And I think they have sort of definitely built a MBA-like ecosystem just in how the employees work. You stay there for a few years. That's the entire philosophy of how a business is run. If you are ready to learn that, and some people can also spend some time and not learn that.
Some people don't like Amazon because it's a slightly workaholic in nature, especially our team was. I can't comment about all other teams. We were a young team in terms of we had so much to build.
Right.
And there was always work pressure. Some people did not like it and they left. And I think that was right for them. Right? But for me, I enjoyed it. For me, it was like again doing a startup. But of course, with somebody paying a very cushy salary and getting to learn from VPs and SVPs at Amazon, because I was there in the one-pagers. Amazon has this one-pager and six-pager culture.
Right.
Where you write down very crisply what you want to get done and why you're building what you're building.
Right.
So learned a lot there. 5 years, we set up with help of a lot of colleagues and friends. Again, good friends. I keep meeting them whenever I'm in Bangalore. We built that whole team for the ad tech in Bangalore. Then we wanted to grow it in Silicon Valley.
Right.
So I moved to Silicon Valley for a while. Again, it was another exposure because then I got to interact with a lot of fast-growing tech. Like MongoDB was right next door to us.
Okay.
So whenever they had an event, I would just go for coffee discussion and figure out ki kya ho raha hai.
Right.
Then Databricks was just set up around the same time. We were one of the early teams which was using Databricks and Spark for petabyte scale machine learning and deep learning. And we said, "Okay, let's go." They're just like a stone's throw away. You can go for an evening coffee if they're having a tech talk.
Right.
So learned a lot from there also. 5 years at Amazon, you get a yellow card.
Yeah. I have seen LinkedIn.
Red
people
card
post,
is 10
right.
years.
Yeah.
Yellow card means time to go.
Blue, yellow, red.
Blue is default.
Blue is default and then it becomes
Yellow
yellow. then
becomes.
it goes-
I was about to get my yellow card. Amazon stock went through the roof. Okay. So I said, "Okay, now I have enough money to go back and do startup. I have more skills today."
Right.
Right? Because earlier I didn't know what business was. Now customer obsession became the takeaway.
Right.
But there is one more thing which was missing in Amazon's philosophy, which we incorporated partially into our teams, which was employee centricity. Like we said, because we built what we built because our team was terrific. Like our team, a lot of our early team members went on to do phenomenal things later.
Right.
So that employee centricity was something that was missing in the broader Amazon leadership principles, but we incorporated in our team.
Right.
By accident, because we didn't want people to leave. Simply put,
Yeah.
we were practical that way.
Correct.
5 years later, we had enough money in the bank. Amazon stock went through the roof. I said, I want to do a startup. I wanted to collaborate with a friend of mine, 1 year junior of mine, who was doing an edtech startup. My plan was, okay, let's move back to Hyderabad because my Silicon Valley money can survive much longer in Hyderabad.
Right.
Even Bangalore was expensive. Relatively, Hyderabad is cheap. I speak the same language.
Yeah.
I have my family and friends there. Let's go through it. My wife and I said, okay, let's experiment with it. Anyway, thankfully, I'd never taken home loan. So no headache. So I would say, don't take a home loan if you want to start up.
Yeah. True.
Then we simply said, okay, we have enough money to run for a few years. let's experiment and fail. If we fail, I can always go back to Amazon. Or I can go to any of the FANG companies. I wanted to collaborate with a friend. The collaboration did not work. But then I found I had got a terrific team of co-founders. At Applied Roots started as an accident.
Okay.
I enjoyed teaching. I always used to joke with my parents that, not joke, actually I was serious, that I want to retire. I want to make enough money in Silicon Valley, retire and come back to Vizag or Hyderabad and teach. Because I enjoyed teaching.
Right.
It's more like pure joy.
Right.
Then I wanted to collaborate with a friend. It didn't work out, as I said. And then I said, my co-founders had a tech background. And they said, Varma, you teach well. Why don't we start some teaching? I said, what do we teach? Then we started doing basic market analysis, working backwards from the customer. We said, AMA, there is a gap. And I felt this as a hiring manager. I've done hundreds of interviews at Amazon. One thing that I found was what people were being taught in universities and what industry needed, there is a huge gap.
Right.
There was such a huge gap that for the first 3 months of any employee joining my team, we would just make them do raw data analysis and nothing else. Because we wanted them to understand the data thoroughly.
Right.
So Applied AI started through a series of accidents, mishaps and everything. But then we said, let's do one thing. We build the best AI course that we can at this price point to target these audience.
Got it.
And then we said, let's build the best we can. My co-founders also, surprisingly, even though they never worked at Amazon, they had extreme customer centricity. So it was a marriage made in heaven for all 6 of us that we all always focused on customer first.
Right.
And then Applied Roots happened, and then we launched a series of programs and courses there. They took off very well. Our learners loved them. We started getting great success from learners. That's what matters at the end of the day.
Right.
In EdTech, the learner success is what matters. And that happened. And again, thankfully, we bootstrapped. We were very lucky. We just invested some money from all of our savings. We bootstrapped our way. We had some options to raise capital, but we said, hey, we have enough money to run for a couple of years, even though I don't make a rupee from tomorrow. We were very frugal. Frugality never left us. Okay. So we said, let's keep all the money in the bank so that even if we don't make money from tomorrow, we can pay our employees' salaries for 2 years.
Right.
Like even in the peak of COVID, we said employees are our strong force. Right. We have to take care of them. You take care of your employees will take care of your learners or customers. Right. Simple logic. And thankfully, we hired a lot of people who were our learners at some point. So they could empathize with the learner.
Correct. That happens.
So that empathy actually naturally came to our teams.
Right.
And over a period of time, we grew quite well. We were self-sustaining. We were profitable. Profitable matlab we would put the money in the bank and use it to start new programs.
Correct.
And then SCALER acquired us about 6-7 months back. And then this feels like second home now. Because I see the same customer centricity.
Yes.
Again, that's the only reason why we were okay getting acquired by SCALER. Because when I spoke with the co-founders, investors, the customer centricity and making ourselves responsible for customer success.
Yeah.
That was the core ethos, which I see missing in a lot of edtech companies.
True. So when I had joined also, I remembered I talked to Abhimanyu Anshuman, and I had been talking to at least 5-6 more edtech companies, and I talked to them in first time, Abhimanyu, in fact, when I first talked to him, I was like, okay, these people finally found someone who thinks like me about education, and I was like, this place I would feel like home.
Yes, same thing happened to us, and the SCALER acquisition happened, and then now things, again, at SCALER, the last 7 months has been terrific, because I love building things from ground up. While it's hard, it's fun. Because that's where you have great stories to tell your grandchildren.
Yeah.
Otherwise, what's the fun of doing all this?
Right.
So 7 months we grew. Our learners are now, the early set of learners are now graduating. Right. We see a lot of potential in this. Our whole curriculum, we had a ton of great instructors who are, again, the backbone of the whole team now, right?
Yeah.
So things have been going good. And again, we have just launced SCALER University very recently.
Yeah. I've been working closely with Naveen for that.
So we started this project almost 3 years back. So SCALER University happened through the acquisition. It was Applied Roots College and then became SCALER University. We wanted to set up our own academic institution. Because we felt that we are anyway teaching on par or sometimes even much better than the top universities. People are putting in the effort. Why don't we give them a degree? Simple logic.
True.
So again, things have been going great, and there are tons of great programs, 18 months, that I can't publicly reveal. But as time progresses, everybody will hear about them.
Right. So I would like to definitely continue this conversation, especially about I am definitely seeing the data science vertical growing, and then so many also students coming in. One of the things I also have been doing very recently is hearing a lot of these our recordings with our counselors as well, because they're trying to build better, more aware conversations that our counselors can have with prospective learners, right? Because I think it's our responsibility also to be able to help them what they should do as well.
Oh,
Because a
yes.
lot of times people are coming fairly, I would say, I wouldn't say confused, but fairly unaware, right?
Happens all the time.
Right, and then sometimes the people 3-4 years they have spent in a service company, maybe haven't actually gone very deep into tech also, but they now want to do that, and they talk with our counselors, and I have listened to some of those recordings, and they're like, should I do web development? Should I do data science? And and it sometimes veers into, okay, where is there more money? I have heard there is more jobs in data science, right?
Yes.
Saw some YouTube video, saw some Twitter thread, and there is more job there. And even sometimes, our counselor is telling them that, okay, what is it that interests you? What is that you should do and all? And maybe somebody saying that, okay, they have been working with data and they are interested, but they want to go into web development because there is more jobs there, they have heard. Or the vice versa also, exact same opposite also happens. They're good in software engineering, but they want to go into data science just because they have heard from somewhere, right? So from that perspective, I would like to, actually take this opportunity to break down a little bit also about, so when we say, let's say somebody is a data scientist at a fairly big company which deals with a lot of data, what does it really mean? Like, what's their day-to-day job? And this is something that people don't talk about. People talk about this much lakhs of salary and this much scope and all, but what is a data scientist?
Huh. So the title itself, the terminology itself is self-explanatory.
Right.
There is data and you have to be a scientist. What is a scientist? You take some observational stuff, you make sense out of it. You derive insights from it using a bunch of scientific tools.
Got it.
In data science, it is mostly math and code.
Okay.
And the data that the see, for example, imagine if you're an astronomer. Okay, what is your data? It's all celestial objects, their movements, or some X-ray data, cosmic ray data, all of
Sure.
that stuff. That's your data.
Right.
They apply same tools. There is some physics fundamentals that they use,
Correct.
and there is math and code that they use. Data scientists, give me any data. It could be e-commerce data, it could be web streaming data, any data you give me. I'll work with the domain experts there,
Right.
right? And I will try to make sense out of it by using a bunch of tools.
Right.
But one thing that is often missed and not emphasized enough
Right.
is the data part of it. Lot of people are too focused on the scientist part of it. Okay, I will build fancy models, I'll use math equations that nobody understands. Everybody wants to become the Sheldon in Big Bang Theory. Okay?
Yeah.
Nobody wants to do the drudge work. But a real data scientist job, realistically speaking, is 60 to 70% of just getting the data. Because your data realistically may be in 10 data stores.
Correct.
First, get all the data in a single place so that you can even analyze it.
Right. Right.
And that's non-trivial.
Yeah.
Because you have to talk to 10 teams. Each of them have their own formats. Each of them may have different data stores to start with.
Yeah, that's what I sometimes think, because when I worked with large scale systems and people talk about data, and I think that you're talking about all of these things, but the logistics of this putting that data in one place is so challenging.
Is non-trivial.
Huh.
And I've been there have been projects where I spent 90% time there.
Yeah.
Because I have to talk to 10 teams in 10 geographies. Somebody is using some Oracle data warehouse. Somebody is using a Spark cluster. Somebody is using some MongoDB. Data is in 100 places. First, get everything in one place.
Yeah.
That itself becomes a challenge.
Right.
That's why there is a lot of demand now for data engineering talent.
Right.
Because they are good engineers who can orchestrate all of this, get everything that the data scientists, data analysts, and engineers need. Right? So that's one aspect of it.
But the infrastructure has to be built to be able to look at the data even.
Yes. Just to get the data in one place, to be able to apply even a simple mathematical model to it.
Right. Right.
That is often underlooked, but that's equally important. So, but what happens in the industry, that's why in industry, SQL is given so much importance.
Huh.
Well, people think SQL mein kya hai? It's just a bunch of queries, some nested queries, etc. But in a day-to-day job of a data scientist, it is critical.
Yeah, I mean, when you have millions of rows, if the DB is indexed or not makes a
That
difference
itself
of
changes
minutes or
everything.
seconds.
Yes.
Right.
So that's one aspect of it. Then once I get the data, lot of people directly jump to the most complex model possible because they want to show that I am the Sheldon. Na? No, that's not required. Very often, simple statistical techniques, simple plots
Right.
can throw so much insights. Simple data cleaning, a lot of people don't do. Simple, just looking at the data. What is the image? What is what? So if you're doing image data or text data, just looking at the raw data. That is extremely important and overlooked. Just data quality, data cleaning, because they don't sound fancy.
Right.
The problem is they never sound fancy.
Yeah.
So there is drudge work, but that's important. If you have, it's like garbage in, garbage out for models. You put garbage data in, you get garbage out insights.
Right.
So that's a critical part. And now when you do insights, you have to be smart. I think it's like problem solving at the end of the day. You have to ask the right questions.
Right.
You have to use the right mathematical tools.
Right.
While using the right mathematical tools is important, equally important is asking the right questions.
Right. So I believe, like, I mean, what I'm understanding is, and I have a very interesting story to tell you also. So more than just being a nerd about what models you're using, sort of understanding the business context or understanding, I mean, why do I even need to get insights out of this data? That is fairly
Far more
important.
important. Because your delta of lift from using a basic model to a complex model might be 5-10%. But if the problem you're solving is wrong, you're going in the right, see, it's like, suppose I have 2 tracks to go to.
Right.
If I'm going in the wrong track, it doesn't matter how fast you go. You're going in the wrong direction. Same logic here.
Right. Right.
Ask the right questions which are aligned with your business outcomes.
Right. Right.
I'm not saying that you should not know math. Math is a tool. We should never forget that math and code are tools to achieve something.
Right.
The more math you know, the more tools you have at your disposal. That's it. Of course, as the data changes, you have to use different types of mathematics, which is equally important. So a data scientist spends a good amount of time on data cleaning, data obtaining, simple data analysis, some time in building models. Even building models, everybody is too fascinated with just building a model, not debugging the model. Suppose I have some data.
Right.
My model works well on, let's say, 90% of the data.
Right.
The 10% it doesn't work. Very few people, unfortunately, are not looking at why it's not working on the 10%. That is a right question to ask.
Right.
Because you can make that not working on 10% to not just working on 1% by just changing small tweaks in data or small tweaks in model. Right? So a data scientist's job fundamentally is whatever data you get, sit with domain experts, understand the data, make sense out of it. If required, build models.
Right.
If required, not always. Analysis is mandatory. If required, build models. You can use models for analysis. That's the best way to do it.
Right. Right. Right.
So that's what a data scientist is. If you cut all the fad part of it, there is a lot of fad, right? That's a reality of it.
Right.
But there is still a lot of value. Because you can fool 10 people. You can't fool a million smart engineers, scientists, and business leaders, right?
I mean, you can't fool the top line and the bottom line.
Exactly. You can't fool that. Exactly. You can't fool a P&L statement.
Yeah.
So there is value. No doubt about it. There are great careers to be built in it. But we should not misunderstand that data scientist is all about a bunch of equations that nobody understands. It's not that.
Yeah. In fact, so that's why I was telling you this story. It's a very funny story. So this was COVID had just started, right? And colleges had shut down. So semester exams were not happening. Exams got cancelled. 2020, mid of that, right? Final semester exams of colleges, there were problems with that. So there was this one guy in college, I think junior from my college only. And on LinkedIn, he had made a post that they have done some machine learning project. They were using, and I might be wrong with this term, there's some convolutional network used, some net they had trained. And what the purpose was, they had taken the marks of all students from first to, I think, 6th semester, which marks were all available, put it into that model. And that model was predicting their 7th and 8th semester marks. So that person wrote about it and they said, I want the colleges to try this model, and with that, they don't need to take exams in 7th, 8th semester. So the fun part is coming. So the college don't need to take the exam. This can predict what their marks will be in 7th, 8th semester. And they had submitted the raw data, and they had also done a validation they had done with some older students whose all 8 semester marks were available. They showed
Fair enough.
1 to 6 put into the model, showed the results, and then actual 7th, 8th semester what marks, and they showed very close prediction with that. So I just pinged that guy, asked him. So I said that, okay, let me do something. If I just take the median marks that they have gotten till now, the average, and I just say that this is the predicted marks for 7th and 8th semester. So I wrote a script, Python script, in Python, not even my first language, but his all stuff was in Python. So I took it to GitHub repository. I added a separate Python script. I read option B, Python script. It just takes averages and predicts.
That's it.
And I said, let's match this to the validated data set. And that also matched almost same. His model had some 97% accuracy. I think mine one had, same 97 point something only accuracy. I'm like, so this model, can you just explain what it does? And I believe he gave me a good explanation. I did not understand much. I mean, it's not my field, to be very honest, because how a CNN works and all, I could not really understand. But then I just felt like, why are you doing exactly this? Because, I mean, the number of CPU cycles required to average numbers is much less than whatever you have built. I said, on what model how have you run it? He said, like, I have CUDA and NVIDIA GPU, and on my PC, I'm running it. I'm like, this runs on 5 minutes inside my laptop.
So this brings me to something very fundamental. Again, a very common mistake of beginners, which is, we double down on this a lot in our classes also, which is always build a baseline dumb model. Your median model, I would call it a baseline model.
Yeah, I mean, there's no learning in it.
There's no learning.
But at least it makes some sense.
Imagine if you're a non-data scientist. You're an engineer who can code. Or you're a 12th class kid who can code.
Right.
You only know 10th class math. You don't even know 12th class math. You don't know calculus. If you give this to a 10th class kid, a smart 10th class kid who knows programming, this is what he will do.
Yeah.
And that's our baseline.
It's the common sense baseline.
Common sense.
Whatever the final prediction, it should not be way off from this at least.
No, the point is this. Now, any model that people build, they should compare with this basic baseline. What people do is they don't do this only, They directly, because they want to show that I've built some fancy stuff.
Yeah.
They forget the fundamentals that you always build a simple model.
Yeah.
It's called the Occam's razor in our world. Always the simplest thing that explains, pick it. Now imagine if I build a very simple median model that you're suggesting.
Right.
Simple, extremely simple model. If it has some performance X, I build a complex state-of-the-art neural network model and I get Y. If X and Y are very close, I'm just wasting time.
Yeah, that's right. I mean, the achievement is not the 97% accuracy. The achievement is if you went from 97.1 to 97.5, then there's just the 0.4 is...
If you went from 97 to 99, then I will listen to you. 0.1, though, it could be just a random, it could be just because of the randomness in the data also, no?
Exactly, that's what I'm saying. So if the median model is giving 97.1, your model is giving 97.4, then...
It's useless.
the achievement is only 0.3. The achievement is not the 97.
And that 0.3 doesn't make much impact, real world impact in this case. See, 0.3%, imagine at Google scale, for their ads models, 0.3% improvement in their models. Is a few $100 million.
Yeah, here with 500 students pass, fail, nothing is changing.
The world is not changing here. So I will not completely say that 0.1% improvement or 0.3% improvement is useless. I would say we have to contextualize it with the business problem we are solving. For 500 students, for just telling them how many marks they'll get or they'll fail or pass. See, for example, imagine if a person is just failing, no?
Right.
Pass kar do usko. Because your model could be wrong, for all you know.
Could be wrong.
Model will always have error margins, no? I would have been very happy if this gentleman actually predicted the median and gave a confidence interval around it. Simple confidence interval. We learn in our, I think, engineering first year, second year. That would be good. And always give the benefit of doubt. COVID time hai, kya karenge? Let's give the benefit of doubt to students.
Right.
I think in some states and in some boards, all 10th class kids who just applied for the 10th class exam were passed. वो कर दो ना.
Yeah, right. Makes sense. So another thing I'd like to ask is, I mean, just because of this example also, here in our program, I have kept hearing from both teachers as well as students a lot of good words about our business case studies. So how are those formed, and like, can you share some examples, and then how do they impact the learning?
Cool. That's actually one of the best parts of our program.
Yeah.
And we intentionally made that choice from the very beginning. That what we want to teach has to connect to the real world. We will teach all the theory, but the theory has to be the context of a real problem. I'll give you a simple example from a case study that I just taught yesterday. Okay. Again, some of our case studies come from industry relationships. Like we talk to a company and they share some data sets of theirs. They give a problem definition and we bring that problem into the class and we solve it along with students.
Okay.
That's one type of case studies. The other type of case studies where we may not be able to get data. For example, I'll tell you a case study that I was just teaching yesterday. We had a data set of your video recorders, right? Your CC cameras basically, recording from schools and public places. And we have to detect whether there is a gun in the video or not.
Okay.
Because of school shootings in the US and all, right? Public spaces shootings. We have to just detect if there is a firearm, typically a gun.
In that video.
In that video that somebody is carrying, and we have to detect that.
Okay.
And we took publicly available data sets. Because we cannot go to a law enforcement agency and ask them for it.
Right.
Okay, we just took publicly available data. We started with this problem. And the discussion starts in the class like this. Using all the techniques we learned till now, let's solve this problem first. We would have a very, again, baseline model. Right? We built a baseline model in the class. We coded it up. We said, this is working reasonably okay, but can I improve it? Baseline model was built using everything that we learned till now. Wherein it has a decent performance, not great, decent performance. Then we said, where does this fail? If somebody has 5 guns, or if there are 5 people carrying guns, this model was failing.
Okay.
Then we said, hey, here is where it's failing. Now, how do I work it out? Then we introduced them to new concepts. Then I took them to a research paper called RCNN from the late 2013. We said, how did these guys solve it? So it becomes more or less like incrementally solving a problem better and better. And for them, they have to realize why existing techniques fail there. And why a special thing is needed in the first place. Then they will never forget why they're learning that research paper or why they're learning that technique. And we incrementally build it across 2 classes.
Right.
And we show them that, yes, the final models that we study are truly state of the art, that you can actually deploy it on a CC camera and build a startup around it. Because this is like a major security issue in some parts of the world.
Right.
So this is the basis of our whole case-based approach. Take a problem, solve it using techniques you know. For example, the very first case study, we solve it using nothing more than averages, median, mean, mode, nothing more than that. That's the first case study. Because everybody knows, we teach them, we recap what is mean, median, mode for them. They probably learned it in their high school. No? Using that, we solve the problem first. Then we say, hey, this is where it's failing. Now, how do I improvise on top of it? So all case studies are like, start with a problem, learn techniques, learn tools. As I told you, math is a tool, coding is a tool. Learn tools to solve a problem, then you'll never forget it in your life. This gun example, I hope that the learners that I was just teaching yesterday, they won't forget in their life.
Makes sense. The other thing is because, we were talking about something like, just sort of predicting numbers to, like, say, finding out guns in a video. The other thing I have heard from a lot of people when I'm talking to them about, career choices in data science and all, people are often fairly confused about what all strands this career can finally take. Because, people are looking at these days what DALI and stable diffusion and everything. Okay, from generating art to, computer vision, there's NLP, or just simple, business analytics out of data. And I think we even at Scaler, we have, I think people can opt between data analyst, data engineer, data science, machine learning. Okay. The funnel is pretty wide on that side. So if you could just give me a little bit of idea about what are the different, end goals that are possible, so and what people might be interested in based on, where they go.
Got it. Fair enough. So there are 5 types of roles that we typically see in the industry. The titles might be different.
Makes sense.
So there is a data analyst.
Okay.
You see titles like data analyst, product analyst, supply chain analyst, banking analyst, finance analyst. So that's an analyst job. Data analyst is a core job.
Okay.
I'll first list all of them, then I'll go into the internals of
Makes
it.
sense.
Second is a data scientist.
Okay, analyst then scientist.
Then you have a machine learning engineer.
ML engineer.
Then you have an applied scientist.
Okay.
And you have a research scientist.
Okay.
Okay. 5 roles.
Okay.
Let's go from here to here.
Okay.
So data analyst is somebody whose job is simple. There is data. Take the data, pre-process it, clean it, make sense out of it using simple plotting and statistical and math techniques.
Right.
If you can use simple models. You're not expected to use state-of-the-art models or anything complex.
So for a role like this, even Excel and Metabase would be a very big friends.
That will be a good start.
Good start.
Good start, for sure. Like, for example, in our data analytics and data science track, we teach Excel. Because tools do not matter to me.
Of course.
In Excel, I can build a linear regression model today.
Yes.
It doesn't matter to me. For me, it's just a tool. Like code is a tool, Excel is a tool, Tableau is a tool for me. For me, what I care about is insights. What tool you have used, I don't care. So analyst job is not that trivial. While the tools are, somebody might say, hey, Excel mein kya hai? What is there in Excel to learn? No. It's not about the tool, it's about what you can do. Suppose imagine you are at Scaler. Let's take this example, right? So you have data about tens of thousands of learners.
Yeah.
Imagine you take all this data and you find an iota of insight. Suppose there is an insight which says, hey, I see that people who are not doing their assignments on time for 4 weeks, if we do an intervention wherein somebody from our team calls them and talks to them, then their adherence to the program has improved after that. This data probably is sitting somewhere.
Yeah.
They just they asked the right questions.
Right.
And they found this insight. Imagine if I productize that, which is simple. If somebody is not solving assignments for 3 or 4 weeks, I make sure there is a meeting with a mentor, or meeting with my ops team, or meeting with my instructors, where there's a 15 minutes call scheduled. That way, if my learner outcomes improve, if learner adherence improves, that is huge business value.
Makes sense. Yeah.
Not just business value, we are changing lives.
Yeah.
Business comes secondary.
It's outcome changing feature.
Yes. And this is something that a data analyst can do.
Yeah.
And data analyst can do this in Excel, Tableau, Power BI, you name it, I don't care.
Correct.
What I care about the insight.
Yeah.
And how we have done the analysis. Like I can do all sorts of statistical techniques in Excel, doesn't matter. I'm sure people at Microsoft are pretty good guys that they've written the code well.
Yeah.
Right? So that's what a data analyst is.
Makes sense.
And there are more data analyst roles. Because there is more data sitting there. People want insights. See, imagine if I'm designing a product. For example, I think you're writing a small app right now, right?
Yeah.
For our internal use.
Yeah, internal use.
Now imagine you have a data analyst sitting with you who takes the data from it. It's usage data, it's metrics data, all of that. And then they come up with an insight to you.
Yeah. We have done it using Excel only.
Exactly. Doesn't matter. Tools don't matter
Exactly.
to me. You use any tool, boss. Tell me what is the insight and justify that insight from first principles. That's all. You can do it using GPUs. I don't care. Do it using Excel. You do it using Google Sheets. I don't care.
Right.
I want insight. Now, that's what a data analyst is. I see lots of companies hiring data analysts to work very closely with program managers and product managers. Because there is data sitting there.
Because they are the ones who need the insight.
Yes, who need the insight. And they may not have the tools to do it. Like I was talking to a very fast-growing unicorn fintech startup where one of my friends heads the data science.
Right.
I was just talking to him to see if he's interested to hire our Scaler folks. He said, Varma, I have X number of data scientist positions and I have 8X data analyst roles, because for every program and product manager, they're asking me for data analysts. I need them. Please give them to me.
Makes sense.
And data analysts, even if you're coming from non-tech backgrounds, you can pick up the skills. You have to learn programming. There is no escape from that.
Makes sense.
But you can still learn and excel there. All you need is an inquisitive mind, a business sense. Data scientists are data analysts, plus they have to know a wider spectrum of techniques. They have to know more machine learning techniques, more deep learning techniques. They might also have to know a little bit of data engineering. When I say data engineering, I mean, they don't have to be able to build it, but they have to know basics of how to write a Spark SQL, how to get data from a NoSQL database. Basics. But their breadth of knowledge has to be more. They have to know, for example, a data analyst may not be able to work with, let's say, image data or text data. But a data scientist at a top company is expected to know some NLP techniques, some computer vision techniques to work with them.
Right.
That's data analyst. An ML engineer, think of that person as 50% data scientist, 50% software engineer.
The ML engineer.
The ML engineers. They have to know all your distributed systems, how to deploy a model, your whole Docker, Kubernetes ecosystems.
Yeah.
They have to know that because they
Putting
deploy
into
models.
Production,
They
have
have
to
to
know the logistics of code.
The logistics of code, deployment, code maintenance, testing code, all of that they have to know. they have to deploy low latency, high throughput code oftentimes. Or they might have to write code that works on smartphones. So an ML engineer is 50% software engineer, 50% data scientist.
Yeah.
Then you have applied scientists. Their expectation, again, depends from company to company, to team. They're expected to know the bleeding edge.
Okay.
And be able to apply bleeding edge to solve the hard problems.
Okay.
So the expectation on depth is more for an applied scientist. Then the fifth role is research scientist. Those are people that you find in Facebook AI research or Google DeepMind. They push the boundaries of research. At Scaler, we don't prepare people for this. We don't prepare people for research scientists.
I think nobody can prepare. I mean, people who are
People
interested
can
will
prepare
get
themselves by doing a PhD.
yeah.
And by publishing like great research work.
Right.
So we don't, while we do cover state-of-the-art research papers, this is not our target. The rest four are. So our learners could become anywhere from a data analyst all the way to an applied scientist.
Got it. Understood. And what about like the domains also? Like how much? I mean, I would say similar or related, or how different are they? Like, for example, speech to text, text to speech, voice analysis kind of stuff, to generative art kind of things, and sometimes you're working with fairly raw financial data. There's no image or text in that, right? So between these domains, so how much similarity, or like once it becomes data, it's all the same? How is it?
No. The techniques also change.
Okay.
For example, you're talking about convolutional neural networks a while ago, right? They're typically used on image data.
Okay.
So if you have image data today, everybody uses some form of convolutional neural networks or something called as a vision transformer, which is a very last 1-year-old research work. So the tools that you have at your disposal change based on data that you have. With finance data, you have to have a lot of domain knowledge. See, we should never think that domain knowledge is not important. Domain knowledge is extremely important. Because finance domain data is very different from audio speech signal data.
Yeah.
For them, if you think about pure data, both are time series.
Huh.
But that time series is very different from speech time series.
Yeah, that's what I wanted to know. Like,
So, no.
Is all
So
data same or is
No. You have to use the right technique, and that's important. For example, what we use for speech could be very, very different from what we speak for financial data analysis.
right?
They may share some techniques, but the tool sets have also been customized to work. Like there is wavenets and other stuff, right? Which are very customized for audio data.
Right.
Which may or may not work very well on financial data. For financial data, very little research is published because there is money to be made. So to put it simply, while the foundational mathematics is the same,
Right.
the tools are different. Think of it in your world of software development, using different libraries for different tasks. The programming language is the same.
Right.
You're using different libraries and different tools for different tasks. For us, the math is the same. At the end of the day, everything is basically some linear algebra, some matrix algebra, some calculus, and some coordinate geometry, and some prob stat.
Okay.
That's the basics. Everything is built on top of it. So there are differences, and that's one of the reasons why data science becomes a very broad area. Because I mean, it's compared. See, if you want to become a software developer, you need to know some programming language, a modern programming language, data structures, algorithms. You can become a SDE1.
True.
Simple. In our world, the breadth is so much. You have to know simple probability statistics, some plotting techniques. You have to know some basic machine learning techniques, some basic computer vision techniques. So the breadth is wide because the applications are also that wide.
Okay.
And it's less standardized. The interview process is also less standardized.
Actually, I would like to ask you about, let's say, the interview process also. So we were talking about these roles. Let's go with the, let's say, first three roles itself, like, analyst, ML engineer, and data scientist. Right? So if you're trying to hire for a role like this, what exactly are you looking for in that person? And generally across the industry, what do you see? Like, how are these people tested? Like, is it case study based? Is it interviews? Are people asked to code? Does this happen?
So my experience has mostly been at FANG companies or startups that I have built. So I'll base on that. It might change from team to team, org to org.
Fine.
First is they often have a programming round for all roles.
Okay.
Programming is mandatory.
Basic programming, you must need to be able to.
It will not be it will not be like your data structures algorithms heavy. It will be some simple data pre-processing. Like for example, I've seen people ask, let's just implement simple join from scratch.
Got it.
Nothing complex.
Makes sense.
You have to know basic space and time complexity, basic data structures.
Yeah.
Inbuilt data structures in Python work.
Got it.
So simple questions like that. Or they might say, hey, you know this technique in statistics. Can you implement it from scratch?
Okay.
Simple stuff. So one programming just to make sure that people know how to code.
Right.
And for some of the roles and some of the teams, people also ask SQL in programming round because it's important. You have to use it every day.
Makes sense.
That's one. Then depending on the role, there is a foundational math round
Okay.
where they ask you about the basic building blocks like coordinate geometry, calculus. Depending on the role, the hardness of questions depends. Suppose if you're applying for an applied scientist, the math round becomes fairly heavy.
Got it.
Right? If you're applying for data analyst, they ask basic statistics, basic probability. Right? It's basic sums, maybe some linear algebra, some basic concepts. That's your foundational math round.
Right.
Then there is a breadth round where they want to understand what is the breadth of techniques you know. Then there is a depth round.
Right.
Depth round is pick an area that you claim you have expertise in. Let's dive deep.
Okay.
That's a fourth. Sometimes there is a applications round, or better, in these rounds only that I just told you, which is programming, foundation math, breadth and depth. For example, in depth round, I can start with a business problem, and people actually do that very often.
Okay. Start with a case study.
Start with a business problem. I say, hey, my team is building this. How would you tackle it?
Okay.
And I can keep taking the person deeper and deeper into machine learning and deep learning by just starting with a problem. Or if you come to me and say, hey, I've built this convolutional neural network to solve this problem.
Right.
Then I'll say, what if I change the problem slightly? Or what if I add this new constraint that it has to be deployed on an IoT device? Right? I keep making it more and more complex, put more and more hurdles to see. This tests the depth of knowledge and the problem solving ability. Sometimes there is a dedicated applications round.
Okay.
Which could be like pure, like let's take two problems and let's solve them.
Okay.
So there's a culture fit round, like Amazon has the bar raiser round, etc.
Yeah. Makes sense.
But in general, this is the setup.
Okay. The other question I'm curious to know is also because in software engineering roles, people do ask this question and about like how important is this for the tech stacks? Like, should I know Spring Boot? Should I know Node.js? Should I know React or Angular or stuff like that? And then I realized that the answer sometimes varies a bit also because larger companies are like, okay, you come in and learn stuff here, and sometimes startups and all, they are looking for, okay, our tech stack is so and so, we want somebody who knows this, and then role to role. But I mean, there's an elaborate answer which I generally give people, like telling them what you're interested in and how you go about it. So I want to ask the same sort of question for the data science field as well. I mean, tools I keep hearing, like for machine learning stuff like TensorFlow and PyTorch, and then for data tools like this Power BI, Spark, Airflow, Snowflake, all of that stuff. So are there some of these tools which are absolutely fundamental to learn, or is it that depending on the company it does not matter? Larger companies, you can come in and learn. How is it?
So for most roles, we at least don't have as much craziness as you have in your world, to be frank.
Okay.
Like for example, most of data analysis, most probably people will do it in NumPy, which is numerical Python, or SciPy.
Okay.
Slight variations here and there is okay.
Okay.
But those are fundamentals.
Okay.
Plotting, people use Matplotlib, but there are some fancier tools, fancier libraries. If you know Matplotlib, you're good.
Okay.
If you don't know some libraries, you will pick it up. It's the same Python program at the end of the day. You know the technique, you know the mathematics, you know which plot to do when. It's just about learning a new library, not too hard. Then coming to machine learning, people use all sorts of libraries. New libraries come, new libraries go. There is XGBoost, there is CatBoost, all those things. And there is obviously scikit-learn, which is the most popular, best documented. It's not always the right option, but if you know it, you can pick others.
Okay.
Then in deep learning, you have basically two schools now. One is TensorFlow, one is PyTorch.
Yeah.
Pick any one of them, it's okay.
Okay.
But learn that properly. If you know one, you can pick others very easily. Suppose I come from the school of TensorFlow, PyTorch, because I've been TensorFlow and Keras. I've not used PyTorch much. Because when I started, we implemented all algorithms from scratch ourselves.
Okay.
Then TensorFlow came and saved us. Now PyTorch is becoming very good now.
Yeah.
So if I have to join an organization which uses PyTorch, I'll pick it up in a week. My fundamentals are still there.
Makes sense.
The concept of a computational graph hasn't changed.
Yeah.
Its implementation has changed, that's it. So I would say at least know some basic libraries. Know if you have two options anywhere, pick the most popular, or at least know one of them. Suppose for example, I am not a Tableau Power user. I hardly, like I've used it here and there.
Okay.
But that does not mean that I can't do data analysis. I'll take Python notebooks, I'll take Jupyter notebooks and do all the data analysis.
Yeah.
But I've done Tableau analysis. I've had teammates who'd come up with a Tableau dashboard and show me insights from it. I will learn from them. I've learned Tableau that way through people who are working with me. I've never used Power BI, but if I have to use, I will learn what's there. If you know one, picking the other is easy. It's like I'm not an Excel Power user. Like I have some program managers and product managers in our org who are much better Excel folks than me.
Yeah.
Actually, I was talking to some of our program managers and product managers and I said, guys, you should teach Excel. You're better than us.
Yeah.
Because they know all shortcuts, they know how to do this, that. I don't know all that.
Yeah.
So at the end of the day, know some tools, but be flexible to learn new things as they arise.
Yeah, I think that part of the answer does align with what we tell in software engineering also. Like, learn one tech stack and learn how to build servers well with that.
That's it.
Once you learn that, how the data comes, data goes, how the DB is connected, that, then you pick another tech stack,
That's it.
learn that. Makes sense. And then I think another question is, which is, and I see this often because, I sometimes talk to people who have been a few months into the data science program. It is people get very, I would say, overwhelmed or terrified or sometimes, hitting the wall with the math part.
Yes.
Right. And oftentimes, and I'm not sure if, you can probably add to this, but sometimes I feel that their expectations were also not aligned when they started. They thought that there wasn't going to be a lot of math here. Maybe it's a shorter path into the tech, or sometimes that kind of expectation also I've seen. And once you cross stuff like linear regression and all, and then you know k-means or stuff like that, and those formula and all, it sort of becomes very terrifying. Like back in 11th, 12th grade or college, math, engineering, mathematics books used to terrify people. It seems like it's terrifying in that sense. So I think both parts of the question. One is how true is it that you have to go through a lot of math in this? The other part is like how to sort of overcome that also.
So we have, of course, as we talk to learners on regular basis, we created 2 tracks.
Okay.
We have the AI/ML track, wherein we don't take any shortcuts with math.
Okay.
Because we want people to be the best data scientists, best applied scientists in the track.
Right.
But some students who are struggling, we created the data science and analytics track, which is less math heavy. The concepts are still taught from a very intuitive perspective,
Okay.
but less math heavy.
Okay.
So we did that based on insights that we learned from our learners, number one. Second thing, when it comes to math, right, this is what I've experienced over the last 6 years of teaching math. I think most of us were taught math the incorrect way, from a very formulaic approach. The best way to learn math is basically say, suppose you see an equation. This is what we do in the class. That's what we do in all of our lectures. Let's take an equation, let's break it down. Break it down. If I remove this, what happens? If I remove this, what happens? Why is there a square root here? Why is there a square there? Why is there a log here? Keep removing it bits and pieces.
Right.
And then put it back.
Okay.
So I often tell in the classes that in mathematics, equations are like poetry. They are a crisp way to explain a very deep concept.
Right.
And plots or diagrams are like the art of mathematics. So any equation, so we teach fairly lengthy, complex looking equations in the class.
Right.
The way we arrive at it, we do 2 ways. One is we arrive from first principles to the equation.
Right.
Because I forget these equations. I'm terrible at memorizing them. But you give me 10 minutes, I'll derive it from first principles. Or you show me an equation and say, is something wrong here? I'll break it down. So we teach those 2 skills. And if learners who want to really become applied scientists, the top-notch scientist, math is a fundamental skill along with coding for data science roles in the long term. See, to get your foot in the door, even basic stuff will do. But if you want to build a career for about 2 decades, you have to constantly learn. The world is changing so fast.
Right.
And to learn new things constantly, you have to be strong in math. Or if you see an equation, break it down. Remove bits and pieces. Go from outside to inside. Keep removing. Ask yourself, why is minus here? What if I put plus here? What instead of log, if I do some square root, what happens? That will give you both the depth of understanding and the ability to derive it back.
Makes
So
sense.
math should never be remembered. It should be derivable.
Yeah. Among the teaching approach, I think it's a fairly good point you made, because I still remember this thing back from my school days. So, I mean, there's a proof of Pythagoras theorem in what is there in the NCERT book, right? So, I mean, if you read it and in that age, 6th grade, 7th grade, you will understand it. You will get it. Okay, they mean a plus a square plus b square becomes c square. You get it. Okay, and there is some numerical proof. There is one trigonometric proof. Okay, find something. But then I did this. There was the science fair at school, and I made a small paper presentation on what all different proofs of Pythagoras exist, and there are actually 628 proofs of it.
Okay.
So that was 628 was in 2007 or 8.
Some people would have
Some
come up
people
with
might
more
have come
proofs.
with few more at least. And one of them was by this President Andrew Garfield of he was the president of US. I think he was one of the 23rd, 24th president of US. So James Garfield, I think that's his name. And he gave that proof. And I was very interested in, oh, this is the president of America. He gave a proof for Pythagoras theorem. So he's a separate, I think it's the 300th or so unique proof of it. And it was very different. Like he had a paper cutting approach. Like if you rearrange the cubes and you paper cut it through it and then you put it around the bigger part of it, then you can sort of rearrange the two a squares and b squares. You can cut it and you can arrange it in a certain way that it becomes c square. Again, I mean, the idea is that, some or the other way, like you take those 600 proofs and you talk to different people, it will get into different people's heads using one of the different proofs. And obviously, then as I grew up, 3 blue, 1 brown kind of channels.
Yes, phenomenal channel.
And I have seen some of these, and I see, oh, this formula was there in my college in engineering mathematics. Back then, it was so irritating, but now it feels so intuitive, the way they explain. I think, there is a lot of delta, I feel, in how better you can make it more intuitive. There's also this guy called Stephen Mould on YouTube. Sometimes he talks about waves and equations and all. And he actually makes some practical examples out of it. He takes some trumpet, blowing through that, and then making it transparent and showing, okay, the air, and creating the Laplace transform of it. And that blows my mind. I mean, like, there's this level of delta. If you just throw formulas at people, think.
Yeah. You have to break it down. You have to break formula down.
Yeah.
Even blunt proofs don't work, because blunt memorizing based proofs, you'll never remember them in the long run. See, the proof that you remembered when you're recalling was a geometric rearrangement, because we humans are very visual and we like things that are tangible, right? So what we try also in the class, again, this is lessons learned from great teachers, like even people like Richard Feynman and others.
Yes.
You basically try to draw things. Like whenever somebody asks a question, right, first thing I think is, can I draw it? Because we are very visual creatures. Can I build a counterexample through a graph?
Right.
Or if there is an equation, can I somehow transform this equation into a graph, into a plot or a diagram? Right? So that both poetry and art are talking to each other.
Yeah.
And we enjoy that, right? We remember art faster than poetry. How many poems do you remember from your school days? Very few. But graphic art, we remember.
Yeah.
Right?
It makes a visual image.
Yes.
And there's video of that MIT professor who throws that pendulum and it comes back to him.
Yes. So the whole point is that math education needs, especially math education, needs to be done from a very practical, simplified approach instead of a bookish approach. And I'm glad that there are teachers right now, thanks to YouTube also, we are discovering those teachers, that they're doing it. And that sets the high bar. See, at the end of the day, if a student can find a great teacher teaching Pythagoras theorem proof on YouTube, which is better than my school teacher, that guy will say, this school teacher ko kuch nahi pata hai, I'll learn it from YouTube, na? So, just having access to all of this is increasing the bar for regular teachers to be great teachers.
Fair enough.
Which is good.
Yeah.
Like, I want the machine learning content to be so hard. So, as in hard matlab, so great.
Yeah.
That our bar increases.
I mean, like quality high, but accessible for everybody.
Oh, yes. We teach some very challenging yet interesting concepts called hypothesis testing now.
Yeah.
Including some very complex things like ANOVA to people who come from non-technical backgrounds, who are beginner audience, and they enjoy it in the class.
Right. So I've seen like people even without a maths or an engineering course have been doing fairly well.
Oh, yes, yes, yes. They come from, let's say, non-tech backgrounds,
Hmm.
even non-science backgrounds sometimes.
Right.
Some people come from, let's say, BSc Physics or BCom. All they know is 10th class mathematics, and we build from there.
Okay.
Some people don't know calculus, but we teach calculus. We teach what is a derivative, what is a limit. From a pure applications perspective, we have a problem that we have to solve.
Right.
Basically, we have a problem where we have to find a minimum of a curve. And we come to that problem from a business problem.
Hmm.
And we said, now how do I find it? Then rolling ball, all examples. We motivate why you should learn derivatives.
Hmm.
Then you'll never forget it, right?
Right. Another thing is like moving away from sort of the course and all, because you said you were started a startup where 3D modeling and all you were doing. And then this is, I think people also are looking for, I think, advice on that, and it's harder to come by for particularly this domain, like say machine learning, computer vision, NLP. In fields like this, there are a lot of bright minds who have learned these things, but some of them are also thinking of, okay, I want to do something of my own, right? And I think you were telling about good lesson understanding that, okay, build something very novel, but it was a fad. But any piece of advice for somebody who wants to actually go into, deep tech startups and all, what can they start with and what things they should keep in mind? I would say both in terms of what they are building plus how they should go about building it. Should they raise funds? Should they not raise funds?
Sure. So apart from edtech,
Yeah.
deep tech is one of my first loves. Right? And of course, deep tech, I only have deep tech knowledge in AI, so I can only comment about it. I can't talk about climate change. I know nothing about it. About the deep tech part of it.
Yeah.
I know the general problem that we are through.
Yeah.
So if you want to build an AI deep tech company,
Right.
always start with a problem. Please don't. I see a lot of people who have a hammer and they're looking for a nail. Please don't do that. I've been through that mistake. I've burnt money. I've burnt fingers. I've lost money. I've lost time. First, start with a problem.
Right.
First, start with that. Like I have some students of mine who are now working on a very interesting startup where they want to diagnose mechanical failures using computer vision.
Okay.
And they actually went and talked to final customers who might be their customers. They went to factories and talked to them.
Right.
And they said, this is what we want to build. These guys know all the AI machine learning, right? They want to go build it. But then when they asked me the same question, I said, go talk to your customer first. Step out of the door. Don't sit in your home. Get out and talk. Find what the actual problem is. So always start from customer working backwards. Start with a problem for which people are willing to pay money or for which you can make money somehow later, if not directly from the customer.
Right.
Start with a pain point. If the pain point is your own, scratch your own itch. Nothing better than that. Right? But start with a problem that can potentially generate revenue. Then work backwards and see what can solve that. What might solve that may be a simple probabilistic model. Doesn't matter. You don't always have to do state-of-the-art deep learning to build something complex. Build a proof of concept for them. Start slow. Build a proof of concept, take it to them. See what they say. That continuous conversation with the customer is super duper important. Don't raise funds. I would always suggest people to save money in their work. Be frugal. Again, going back to Amazon's frugality. Bootstrap your startup for as long as you can. Because the moment you take someone else's money, you're obliged to make returns for them. Very simple.
The directions will then change based on that.
You will also get guidance, thankfully, in some cases. If your angel investor or VC has deep knowledge in that, you'll get great guidance. But the fundamental thing is, till the time you're not fully convinced, never go out to raise funds. Bootstrap your way through it.
Makes sense.
Now, once you build version 1, start charging for it. Don't give it free. Start charging for your solution. Again, your customer doesn't care about the complexity of solution. Your customer cares, does it solve his pain point?
Effectiveness.
Does it solve a pain point or does it create more revenue? Simple. If he does that, you price it accordingly, make it accessible, do it properly, get money for it. So that you don't have to keep burning your money or go to an investor.
Right.
But there is a place for investors. There are some startups where you need cash to even get started. Like I have a friend of mine. She's building a deep tech startup to diagnose breast cancers by just using infrared light.
Okay.
I mean, this has to go through FDA, all sorts of regulatory frameworks.
Yes, yes.
And she's been doing it for 6 years. And that costs money.
Yes.
So she has to go and raise money in those cases.
Huh.
If you want to build an e-commerce startup,
Yeah.
you can't do it without capital,
Yeah. Yeah.
right? If you can pick a deep tech company that generates revenue fast,
Yeah.
you are in an advantage.
Hmm.
Because you get market validation quickly, no?
Hmm.
You get very quick market validation. With small investment, you can get market validation, keep growing. At some point, if you need help, go raise from great angels or great investors. That's perfectly all right, nothing against it. But when you take money, always keep it in mind that you have to return at least 10x to them. It's your obligation.
Yeah. Yeah.
There's no legal obligation, but it's your moral obligation to return it.
I mean, that's
So I've
the
never
social
raised
structure of a VC. That's how it
a
works.
VC. If one startup fails, nothing happens.
Yeah.
If out of 10 startups, if 9 fail, one becomes a unicorn, they're happy.
Yeah.
But at a personal level, I've never even taken money from family and friends, even though they offered, because the moment, even if I take my money from my dad, right, I have an obligation to give him 10x,
Yeah.
right? It's just that moral obligation. So I would say build deep tech companies where your path to revenue is quick, right? Then sky's the limit.
Right.
And save, always be extremely frugal.
Right.
Live below your means. I mean, do as best as you can to save as much money for a rainy day.
Right.
If you have money, right, see, at the end of the day, even if you're raising capital, let's say Series A or seed, if you have enough money in the bank, right, you're not desperate for money. You're desperate to find great people to work with, great investors, great people who will guide you and mentor you. Then when you're not desperate in a negotiation, who wins? Whoever is not desperate to win, whoever can let it go wins.
Well, yeah. True.
So if
Basic
you want to
rule.
do a startup, like we were bootstrapped, we struggled for the first 6 months,
Right.
but we started generating revenue and we saved very, very aggressively. Like all of our co-founders hardly took any salary for the first few years. And we saved it because we said employees have to be paid. That is non-negotiable to us. Right? And then save as much as possible. So I don't have to go to an investor, or I don't have to raise money from an investor that I don't like. Like if I want to grow 10x, of course, I'll find the best investor, the best advisor, and get them on board.
Makes sense. One final question, and that would be more, looking towards the future. I mean, especially in the AI and machine learning field, like every day something new is happening these days. Like from, I saw last 2 years, I think, when GPT-3 first model was available, to opening up the platform, to now a lot of these no-code marketing website generator. They are saying that, you just tell in 2-3 sentences what your company does, we will generate an entire website for you. That kind of stuff is happening. Somebody even wrote this thing, I think, with not with GPT, but I think with the same codex that GitHub Copilot uses. Like you tell them that I need a website that does this, they generate the React code to actually make that website. So I mean, going from like, oh wow, to actually application, it's fairly fast cycle. I think with GPT first time I saw that kind of a thing. Then I think with DALL-E and all, people are starting to think that stock images that we use in marketing graphics and all can be generated probably via this. But then I would probably contrast that, self-driving car is something people have been trying for last 20 years. It seems like another 20 years left is also what people say. So what does like the future of the field look like, and people who are sort of getting into this industry today right now, what does it look like going in the next 5 years, 10 years? What do you think? What are you optimistic about?
I'm both optimistic and pessimistic about a few things.
Okay, sure.
I'll quote 2 things before I go.
Sure.
Before I state my actual argument.
Sure.
Jeff Hinton, who is literally the godfather of modern neural networks, he said it's impossible to predict what will happen 5 years later. And I completely get it.
Right.
If you told me 5 years back that DALL-E 2 will, or DALL-E or let's say diffusion models will be popular, I would say, are you joking? And I was reading cutting edge papers.
Right.
5 years back, I would have never guessed it. So it's impossible to predict what comes 5 years later or 10 years later. And that's the first part. The second one is we humans overestimate what will happen in the short term and underestimate what happens in the long term.
Yeah,
I
that's
think
the
I
Bill
read
Gates
this
quote.
in, I think
Gates.
Bill Gates or one of these people. I read it
We
somewhere.
always overestimate what will happen in 2
I think
years
one
and
of these
underestimate in
great
10
thinkers
years.
said that. So let's keep both of that in context.
Right.
Okay, these are not my ideas. I'm borrowing ideas from others. Now, if you keep that in context, I think of it as follows: that more and more areas will be impacted by AI, both for good and bad. For example, look at the stock images.
Yeah.
I think there will be a huge disruption in that space. Some jobs will be lost,
Yes.
but more opportunities will be created.
Hmm.
Like I want, I'm planning to do this, right? I want an image, a custom image, where I will write what I want, and I want to print it and put it in my home, right? Because this is me. I am the creator. I
Yeah.
created this.
Right.
That sense of creation of your own is there.
Right.
Of course, I've been helped by an AI engine, but I provided the inputs,
Yeah.
right? So I think there will be more creators, which is good. Remember, imagine the world before Photoshop,
Yeah.
right? Very few people could edit images.
Yeah.
Now anybody who has a decent computer can edit. So it is a great enabler.
True.
I think a lot of these diffusion models or stable diffusion DALI 2 will become enablers where non-artists like me can still create great art, infusing my personality into it.
Yeah. Yeah.
So it is democratizing that access, number one.
Right.
But it will also displace the stock photography market.
True.
That happens all the time in history, no?
Huh.
When refrigerators came, the ice making industries died.
Right.
When Ford came, your horse carriages died. Happens all the time. Your Sony Walkman died
Yeah.
when iPhones came.
iPhones came.
So it happens all the time. That is natural progression of humanity. So the good part is more things can be done by more people, but at the same time, some jobs will be replaced.
Right.
And it's only foolish on my part to predict anything that will happen 5 years down the line. But if I just follow the trajectory of what's happening, wow, I mean, like, I will be super excited for the next 5 decades.
Right.
Even if we plateau, I'm okay. See, we're going at a very high speed right now,
Yeah,
right?
yeah.
Even if we continue going at the same pace, or even if we slow down a little, or even if we plateau, there is so much to be done. Right? For example, a great specialist doctor, it's so hard to get an appointment now, especially for like cancer and stuff like that, right? So hard to get them. And we all witnessed this in COVID.
Yes.
Imagine if some of this can be offloaded, or if we can make doctors 100 times more efficient, or we can get junior doctors or even senior nurses to perform at the same level as the senior most doctors in that field. Man, that impact on humanity is humongous.
Right. Right.
Right? So my thought process is I'm fairly optimistic that from that front, but I also want to caution that some jobs will be lost, like everything else. Typist jobs went off, no?
Yeah.
When Microsoft Word came. But that is human progression, number one. Number two is I'm also concerned that lot of AI will be used for negative things as much as positive things.
True.
That's true with any
But
technology.
all
you know?
tech happens.
All progress in humanity happens like that.
Yeah.
Like, for example, there are so many models which are heavily biased to people of one race or one gender. And imagine the breaches that have happened at some of the largest social media networks, the security breaches. And imagine how societies can be broken
Yeah.
because people were put in a same bubble.
Yeah. Like
Right?
election changing outcomes.
Exactly.
Can happen.
Election outcome changes. Those are like terrible for the long term of humanity.
Right.
But we have to build technologies to avoid or to mitigate that impact.
Yeah, I think these days companies starting to invest now in AI ethics committees and also because it's required.
Investment is different from impact.
True.
So,
But at least the conversation is starting to happen. I think.
and I'm sure regulation from the from let's say governments is just a matter of time. Right? Again, this happened with print media. It happened with radios. It happened with television.
Right.
It will also happen with internet. Some form of regulation, sensible regulation, to make sure that the misuse of technology is not happening.
Right.
Especially like in the US, right? Extreme republicanism, extreme left wing.
Yeah.
That's bad.
Yeah.
We should, if anything, we should move people to be more centrists.
Correct.
Right? So we should avoid people being in bubbles, and AI can do that. It's just the incentive structure and the regulatory stick is not strong.
True. Yeah.
But both sides of the coin exist. Like when AK-47s were created, I mean, they were terrific for countries which are fighting for independence,
Yeah.
but they're also used by militias for terrorism.
Yeah.
So it cuts both ways.
Cuts both ways. Makes sense. Makes sense. Thank you so much for all these answers. I think I got to learn a lot also myself about how to get into this field, what are the things that exist. So thanks so much for the answers, and I'm sure that people would be, I think, watching this, they would be fairly interested, because we have so far had people who were, obviously, leaders in software engineering so far, and happy to have a guest to talk about this field as well. Maybe more, hopefully more conversations on data science, machine learning.
Sure, sure. I mean, we have a few panelists that I can introduce you to.
Yes, I'd love you
And
to
let's-
recommend some people
Sure,
from
sure.
machine learning, from data science verticals as well, and get them on ScalerPod. But thank you so much for
Thank you,
time.
Arnav. Always great talking to you as usual.
Yeah.